Here you see a property for factoring a sum of cubes and for factoring a difference of cubes. And so what we're referring to here is having a perfect cube plus another perfect cube. This is the sum of cubes factorization. And here is a perfect cube minus another perfect cube, and here's its factorization. A good tool to help you remember how to write this factored form is this notion of SOAP. All right, so think soap, SOAP. All right, what you're going to do here is, if this is a plus, you're going to use the same sign. You're going to have the opposite sign, and then the last one is always going to be positive. Here, this is a minus, so we're going to use the same sign, minus, the opposite, so the opposite of minus is plus, and then the last one is always positive. You do have to have a solid grip on your perfect cubes, all right? So what's 1 to the third power? That's 1. What's 2 to the third power? That's 8. What's 3 to the third power? That's 27. 4 to the third power? 64. 5 to the third power, 125, etc., etc. 6 to the third power, 217. All right, so you do need to be aware of perfect cubes, You can use a cube root function in your calculator if you're off a little bit on those numbers. Another thing that might be helpful is if you are able to list the prime factorization of a number, that can help you identify where you have 3 of the same factors, all right? And so that would tell you if you have a perfect cube. So let's go ahead and look at example 3 from section 6.4. So I'm going to call this 6.4.3. And I'm going to do a couple exercises for you here. We've got 125x cubed minus 27. Since this is a minus sign, we're going to look at this property right here and how this is factored. So I'm saying that this is a perfect cube, okay? It's 125x cubed. That is equivalent to 5x times 5x times 5x minus 3 times 3 times 3. All right, so in this case, A is going to equal 5x's and B is going to equal 3. All right, it's important to be able to identify what A is and what B is because that's going to explain what numbers go where. And especially if we have to square something or if we have to multiply something, we've got to know what those numbers are. So the way I'm going to rewrite this is 5x cubed minus 3 cubed. All right, notice my parentheses, that's important. 125x cubed is equal to 5x quantity cubed. It's 5 times 5 times 5 and x times x times x. All right, so this is A and this is B. So when I factor this, I'm going to have A minus B. That's going to be my first pair. Next, I'm going to take a squared, 5x times 5x, plus a times b, 5x times 3, plus b cubed, b squared, 3 times 3. So this is 125x cubed minus 27 in its factored form, okay? 5x minus 3 times 25x squared plus 15x plus 9. This is the way that we factor a difference of cubes. Now, sometimes the examples aren't, or it doesn't give us a perfect cube. Here, this is 32, which is not a perfect cube, all right? It's 2 times 2 times 2 times 2 times 2 is its prime factorization. And over here, this is 4, this is 2 times 2. All right, so what we need to do in order to factor this is first find a greatest common factor. So that's what we're going to do first. We're going to factor out a 4, and that leaves me with 8x cubed and 1. All right, find a GCF. Whenever we're factoring, that should automatically be our first instinct. Here, this was a perfect cube. There were no common factors. Here, these aren't perfect cubes, and there is a common factor. All right, so look for that. Sometimes you may have a common factor. For example, if this was 64x cubed plus 8, those are both perfect squares. Perfect cubes. And so we could factor out either an 8, or we could work it out as a sum of cubes. And so sometimes there's multiple approaches. But if it says factor completely and you're left with a common factor in one of your pairs, you will have to factor that out. In this case, I factor it out now. That leaves me now with a sum of cubes. This is 2x times 2x times 2x, and this is 1 times 1 times 1. So we will then rewrite this as 4 on the outside times the cube root of 8x cubed is 2x's. The cube root of 1 is 1. All right? So same sign. For the trinomial, all right, we are going to have a squared. A is 2x's, so 2x times 2x gives us 4x squared. A times b, so we need to put minus a times b, that's going to be 2x times 1. And then plus b squared. In this case, that's 1 times 1 gives us 1. All right, now this is completely factored. We took 32x cubed plus 4, took out the GCF, we are left with a sum of cubes, and we factored that sum of cubes according to the property that we are given. You need to commit these properties to memory, and you need to make sure that in order to help you, that you memorize that SOAP. SOAP is probably the best way to approach that. Keeping the same sign, the opposite sign, and the last one always positive, the same sign, the opposite sign, and the last one always positive. Committing this to memory will help you factor these. If you want, and this is what I recommend that you actually do on your own papers, go ahead and multiply that out and make sure that when you multiply this, that you end up with 125x cubed minus 27. All right, so take some time to do that before we get on to example 6.4.4.